Good morning, friends. Up to this, we discussed about the superposition principle, and on the base of this, we also discussed about the constructive interference and destructive interference. Because due to the superposition of the two waves at a point in the medium, either the displacement is maximum or the displacement is minimum. That means in terms of the light, the intensity at that point is maximum and intensity will be zero, that means the minimum. So corresponding to the intensity of the point due to the superposition of two light waves. So here what's happened? The constructive and destructive interference take place. Today we are going to discuss about the constructive and destructive interference in terms of the condition for the path difference and phase difference. What are the path difference between the two waves superposed at a point P or at any point? And what is the condition for the phase difference between the two waves superposed at a point? So which type of the interference take place? Today we are going to discuss about that. Now the constructive interference first we discuss. For that purpose we consider the one figure like that way. Here the S1 and S2 are the two coherent sources. There is the S1 and here there is the S2. These two are the coherent sources. Produce the wave with the same phase. Suppose these two waves are superposed at point P or at point Q. So the wave from S1 travel the distance S1Q. So here the waves are like this way. So here the S1Q length is 7 lambda. 7 lambda. Because the 7 waves are completely lies in this distance S1Q. Now the S2Q. Here the 9 lambda. So there is the one wave, 2, 3, 4, 5, 6, 7, 8. We end down here, one more. So this point is our S2. The separation between these two sources is B. So here the S2Q is equal to 9 lambda. Now what are the path difference between these two waves? Emitting by the two sources S1 and S2. So here there is the 2 lambda. 2 lambda is the same phase. Okay, therefore we write H shown in figure. H1 in figure. S1Q is equal to 7 lambda and S2Q is equal to 9 lambda. Therefore, path difference between them at Q is S2Q minus S1Q. Therefore, 9 lambda minus 7 lambda is equal to 2 lambda. Thus, waves from S1 are at Q by 2 cycles earlier than waves from S2. Thus, waves from S1 are earlier by 2 cycle at Q, then waves from S2. Waves from S2. Clear this? Okay. And the phase is same with the same phase. With same phase. With same phase. Now here, what is the lambda? Lambda is this distance. Last we discussed the distance between the two consecutive cast or the two consecutive tube, that is known as the lambda. Or the distance between the 2 points having the phase difference is 2 pi radian, that is known as the lambda. Now here, distance between S1 and S2 is D. And S1Q and S2Q is much greater than D. And S1Q and S2Q are not equal. But the phase difference between them, both are in same phase at Q. Same phase at Q. Therefore, the displacement of S1 or the waves from S1. Now, the displacement of wave from S1 is Y1 is equal to A cos omega t, equation 1, and displacement of wave from S2 is Y2 is equal to A cos omega t minus lambda. Minus lambda. Or in other words, is equal to A cos omega t minus 2 pi. Minus 2 pi. Because the path difference lambda is equal to, here path difference lambda is equal to 2 pi phase difference. 2 pi phase difference. Why the path difference lambda is equal to 2 pi phase difference? So already we know that here, what is the wave? Where is this? That is the crest and tube. If the tube is made in this side, so what's happened? Our wave is a circle. Our wave is circle. So that is the crest, that is the tube. If the tube is made in this direction, so that is our wave. If the particle, already we discussed in 11th standard in uniform circular motion, one particle rotate on a circular path. So after the completion of the one rotation, so its phase is increased by 2 pi radian. So particle start its motion from this, again return back at that point, so its phase is increased by 2 pi radian. So here, so this distance is equal to 2 pi radian. That is the phase difference is 2 pi radian is equal to lambda. Therefore, path difference lambda is equal to 2 pi phase difference, and due to that reason, here the path difference between the two waves originating from S1 and S2 at point Q is 2 lambda. Right? So here the path difference between these two is 2 lambda. Therefore, the waves from S1 which is at point Q 2 cycle earlier. Therefore, 2 lambda more than it tells the 2 lambda distance less by S2. Therefore, instead of the 2 lambda, we can write here the 4 lambda. 4 pi. 4 pi. Now we know that Y2 is equal to A cos theta minus n pi. So it's equal to A cos theta. Therefore, y2 is equal to, our equation is A cos omega t. That is equation 2. Thus, both waves at point Q having same phase, so that the intensity of point Q is 4I0 maximum. Thus, constructive interference will be formed at Q. Because the path difference is in order of 2 lambda, therefore constructive interference takes place at point Q, and here the intensity at point Q is maximum, is 4I0. Here the I0 is the intensity of each wave. I0 is equal to intensity of each wave. Therefore, the path difference at Q. Path difference at Q is equal to n lambda, where n is equal to 0, 1, 2, 3, and so on. And phase difference at Q is equal to 2n pi. So there is the condition at Q which constructive interference takes place and the intensity becomes the maximum. Again, this side again. Now, we are going to discuss about the constructive and destructive interference. So first we take the constructive interference. For the constructive interference, here we consider the figure. There is only for the explanation. If in exam there is asked, right, only the condition for the constructive and destructive interference, at the time explanation is not required. But if the question is asked, explain the constructive and destructive interference and obtain the condition for it, so at that time you have to write down this thing. Here the figure is shown, S1Q is equal to 7 lambda, S2Q is equal to 9 lambda. Therefore, path difference at Q is S2Q minus S1Q, 9 lambda minus 7 lambda is equal to 2 lambda. Thus, the wave from S1 had earlier by 2 cycles at Q, then the waves from S2 with the same phase. Here the phase are same because the torque of one is superposed on torque of other wave at point Q. Therefore, here at point Q, the constructive interference takes place. So here the distance between the S1 and S2 is D, and S1Q and S2Q is much greater than the D. And also S1Q and S2Q are not equal, but both waves are in same phase at Q. Therefore, the displacement of wave from S1 is given by the equation y1 is equal to A cos omega t, equation 1. And displacement of wave from S2 is given by y2 is equal to A cos omega t minus 2 lambda. Because between these two waves, y1 and y2, here the phase difference is 2 lambda. Therefore, I write down the 2 lambda is minus from y2. Okay. So corresponding to the lambda, here the phase difference is 4 pi. Therefore, A cos omega t minus 4 pi. Now here the path difference lambda is equal to 2 pi phase difference. Therefore, y is equal to a cos theta minus in pi is equal to a cos theta. Therefore, y2 is equal to a cos omega t. Thus, equation 1 and 2 have the same phase. Therefore, at point Q, the constructive interference takes place and intensity will be maximum. Now, after that, we add down the condition for path difference and phase difference for constructive interference in terms of path difference n lambda and phase difference 2n pi. After that, we are going to add down the condition for path difference and phase difference for constructive interference. Okay. Now keep in mind this, why the lambda is equal to 2 pi and what is the lambda. Okay. Okay, now we are going to write down the condition for constructive interference. First, the condition in terms of the path difference. If the path difference between the superposed wave is n lambda, if the path difference between superposed wave is n lambda, where n is equal to 0, 1, 2, 3 and so on. The intensity at that point, will be maximum. And constructive interference will be formed. Constructive interference will be formed. Now there is a condition for the path difference in lambda. But we know that the corresponding to path difference lambda, the phase difference is 2 pi radian. Therefore, path difference lambda is equal to 2 pi phase difference. Therefore, condition for phase difference. If the phase difference between superposed wave is 2n pi, where n is equal to 0, 1, 2 and so on. The intensity will be maximum. And constructive interference will be formed at that point. So there is the condition for the constructive interference in terms of the path difference and phase difference. Sometimes for the 2 marks question is asked, only write the condition for path difference and phase difference for constructive and destructive interference for 2 marks question. Only you have to write down this. For constructive and same for destructive interference. Clear this thing? If the question is asked, explain the constructive interference at the time, earlier part you have to write down with the figure. Clear this thing? Okay. So for path difference, for constructive interference n lambda, and for phase difference is 2n pi. Because the lambda is equal to 2 pi, that means the phase difference corresponding to the path difference lambda is 2 pi radian. So that is the condition for the path difference and phase difference for constructive interference. Now the destructive interference. Already we discussed about the destructive interference is that when the crest of the one wave is superposed on twelve of other, or the 12 of one wave is superposed on crest of other. At that time, the intensity and displacement of the point is 0 or the minimum. So at that point, the destructive interference takes place. So here in figure, suppose the S1 and S2 are the two coherent sources. Now the wave from S1 and S2 are superposed at point R. At point R. Suppose the S1 travel the distance 9.75 lambda. (9.75 R). So S1R is equal to 9.75 R. So this distance is lambda. And whatever the wave from S2, the S2R is the length is 7.5 lambda. So S2R is equal to 7.5 lambda. 7.5 lambda. That is the S2R. The separation between these two sources is small d. Is small d. Now, it's shown in the figure. As shown in figure, S1R is equal to 9.75 lambda. That much lambda. And S2R is equal to 7.5 lambda. Therefore, path difference at R is equal to the S1R minus S2R, 9.75 lambda minus 7.5 lambda is equal to 2.5 lambda. Thus, the wave from S1 L will add 2.5 cycle later than waves from S2. Therefore, path difference between them is 2.5 lambda. Clear this? Okay. Now, the displacement of both waves at R will be in opposite phase, so that intensity at that point will be zero. Thus, destructive interference will be formed. The displacement of wave from S1 is given by y1 is equal to a cos omega t equation 1, and wave from S2 is y2 is equal to a cos omega t plus 2.5 lambda. But lambda is equal to 2 pi radian phase difference. Therefore, y2 is equal to a cos omega t plus pi lambda into pi. Because the lambda is equal to 2 pi, therefore 2 pi into 2.5, that means the pi. Equation 2. Because the 2.5 lambda is equal to 2.5 into 2 pi. Now, but we know that y is equal to cos 2n plus 1 into pi. 2n plus 1 into pi plus theta is equal to minus cos theta. Therefore, y2 is equal to minus a cos omega t. Equation 3. So here the y1 is equal to a cos omega t, y2 is equal to minus a cos omega t. Here negative sign indicates that the phase of the both waves are opposite. That means when the at point R, here the both same phase in same, the crests are not superposed here. So here there is like this way. Thus, waves from S1 and from S2 are in opposite phase and up. Thus, the path difference at R is 0 and intensity is also 0. Therefore, the path difference at R is equal to the n plus 1 pi 2 into lambda, or That is the 2n plus 1 into lambda by 2, where n is equal to 0, 1, 2, and so on. And phase difference at R is equal to, that is the 2n plus 1 into pi. Lambda is equal to 2 pi, therefore 2 to cancel only the pi. Clear this thing? Okay. Or in other words, we can also add n plus 1 by 2 into 2 pi. That is the path difference, phase difference. So there is the constructive interference, we discussed about that. Here the phase path difference at point R due to the superposition of two waves, one from S1 and second from S2. Here we take the example how the crest and term are superposed on each other at this point. For that purpose, we consider the S1R is equal to 9.75 lambda and S2R is equal to 7.5 lambda. Here from S1, the term is superposed with the crest of the second wave at point R. Therefore, path difference at R is 2.5 lambda. Thus, the wave from S1 will add 2.5 cycles later than the waves from S2. Now, the displacement of the both waves at R will be in opposite phase, so that the intensity at that point will be 0. Thus, the destructive interference will be formed. Now, the displacement of the wave from S1 at R is given by the equation y is equal to A cos omega t. Now, the S1 reaches the 2.5 cycle later. Or in other words, the wave from S2 is reaches at point R earlier by 2.5 cycle. Therefore, y2 is equal to A cos omega t plus 2.5 lambda. Lambda is equal to 2 pi. Therefore, A cos omega t plus pi. Now, we know that the cos twin plus 1 into pi plus theta, its value is minus because the pi is added. Therefore, y is equal to minus cos theta. Minus cos theta. Therefore, y2 is equal to minus A cos omega t, equation number 3. Thus, the wave from S1 and waves from S2 are in opposite phase at R. Thus, the path difference at R is 0 and intensity is also 0. Therefore, the path difference at R is given by this equation and phase difference is this. Now, what is the condition for the destructive interference? Right? Now, for the condition for the destructive interference in terms of the path difference. So, path difference for destructive interference. If the path difference between the path difference between superposed wave is n plus 1 by 2 into lambda, or 2n plus 1 into lambda by 2. The intensity will be 0. The intensity of the light at that point will be 0. Thus, destructive interference will be formed at that point. Thus, destructive interference will be formed at that point. Now listen here. What is the value of n? Here n is equal to 0, 1, 2 and so on. The same value of n for whatever we take for the constructive interference. For constructive interference, there is the n lambda, value of the n are same. Now for the phase difference, we know that the lambda is equal to 2 pi. Substitute only the value of lambda as 2 pi. Therefore, n plus 1 by 2 into 2 pi or 2n plus 1 into pi. Therefore, if the phase difference between superposed wave is n plus 1 by 2 into 2 pi or 2n plus 1 into pi. 2n plus 1 into pi, where n is equal to 0, 1, 2 and so on. The intensity of light at that point will be 0 or the minimum. Thus, the destructive interference will be formed. Thus, destructive interference will be formed at that point. So there is the condition for the destructive interference in terms of the path difference and phase difference. Path difference is this n plus 1 by 2 into lambda or 2n plus 1 into lambda by 2. And phase difference is either the n plus 1 by 2 into 2 pi or 2n plus 1 into pi. Clear this thing? Again I repeat, if in exam for 2 marks question is asked at the condition for constructive and destructive interference in terms of the path difference and phase difference, only you have to explain this thing. If the question is asked, explain the constructive and destructive interference, at that time you have to also explain with the example S1R, S2R. Otherwise, only you have to write down the condition. Clear this?